Assalamu alaikum and welcome to you, Doctor. Here is Muhammad Majdi Muhammad Abdurrahman from Group 6, Section 3. And in this video, I would like to present for Control System D-Lab 1. And I would like to start with the first question. So the question says, what are the dependent and independent variables? Simply, both of them are important in a scientific experiment, where the independent variable is a variable that controlled throughout the experiment, but not affected by any other variable, while the dependent variable is the opposite of the independent variable, which make it depend on other factors. So let's get an example. Let's say we do an experiment to test how tall a tree would grow after 1 year. Then, in this case, the period of the time, which is a 1 year, considered as independent variable, whereas the other factors such as temperature, region, height, and so on, considered as dependent variable. So from this experiment, we can conclude that the independent variable and the dependent variable is in the same vein as cause and effect. Both independent and dependent variable may change during a period of time or during the experiment. If the independent variable is changed, then the an effect will be absorbed in the dependent variable. So that's all for the first question. I hope I explained well, and thank you for watching.
Okay, Assalamualaikum and good morning. My name Muhammad Nufidau bin Ahmad Zaki. My matric number CE 190052. So today for the lab control 1, my part is doing the 1.2. So okay, my part is doing for the 1.2 for how we collect the data. Okay, first of all, we identify the problem. Identify the problem is like a problem statement lah. Like a problem statement is a concept of a description of an issue to be addressed and to be improved upon. So the next step is how we determine the data. Okay, determine the data is like we determine the factor. It's like the how the variable that we control during an experiment in order to determine the data that we data that effect on our variable. So after that we determine the number of experimental unit and determine the level of each factor, like the number of variation that we use, and last but not least conduct the experiment. Okay, so conduct the experiment is carry out the procedure lah under control in condition to determine the validity of hypothesis. Okay, that's all from me, and for the other part my group member will do it. So we continue to our next member. Thank you.
Assalamualaikum and hi, my name is Wan Muhammad Aslam bin Al-Asri and my matric number is CE 190007, and for my part is part 1.3. That is how does the analysis will be conducted. That is, the first, a transfer function is a method for expressing the input-output relationship of a linear time invariant system is determined by applying a Laplace transform to differential equation that describes system dynamic with zero initial condition. In the absence of this equation, a transfer function can be derived from particular input-output data. And second is transfer function are instantaneously block diagram representation of system to undertake time domain and frequency domain analysis and control design. Transfer functions are useful because they allow engineers to analyze and create a system using simple algebraic equation rather than complex differential equation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My fellow student and lecturer, my name is Afiq Irfan bin Yahya, and in this video I am gonna explain about the damping ratio. So we need to understand what is a damping ratio. Damping ratio is dimensionless parameter which describe how an oscillating or vibrating body comes to a rest. So basically is that every oscillating system comes to a rest or equilibrium state after a certain amount of time. Take a swing, for example. When you play a swing in the park, after you play the swing will gradually comes to a stop because there is a resistance in the air, so that causes the swing to stop after a certain amount of time. So amplitude gradually decrease with time and come to zero. So any oscillating system will eventually comes to equilibrium state. So this is the calculation about the damping factor. So the formula given with C divided by 2 square m times K. So with C is the coefficient of the spring, m is the mass, and K is the variable. So based on our equation, we replace C with 2, m with 1, and K with 100, and we calculate. So we get the damping ratio 0.1. So based on this calculation, we can conclude that the system is underdamped, as we can see on the graph to the right here. So the system gradually comes to a stop after a certain amount of time. So we call it underdamped because the system oscillates at reduced frequency with the amplitude gradually decrease to zero. So that is the damping factor.